In this video, we're going to look at the angle-angle-side congruence, which states triangles can be proven to be congruent when two angles and a non-included side of one triangle are congruent to two angles and a non-included side of a second triangle. So non-included means that the side is not between the two angles that we're told are congruent. What I want you to notice is that there are two non-included sides. Okay, we have AC and DE that are not included, and AB and EF that are not included. So the key here is that the side is not between the two angles. So looking at our diagram, we have angle C is congruent to angle D, angle B is congruent to angle F, and we can choose one or the other. AC being congruent to DE, or AB is congruent to EF. And if you have the two angles and one of these sides, the triangles ABC and triangle EFG or EFD are congruent by angle, side. All right, so example 1, we are given that angle A is congruent to angle C and AD is parallel to BD. So again, if you have parallel sides, look for congruent angles. Your choices: alternate interior, alternate exterior, or corresponding. Okay. So this is what we're given. Now, if these are the two parallel sides and this is the transversal, then we have alternate interior angles here. And we have to use 3 letters because D has two angles, or two triangles that share the same vertex, and the same thing up here at B. So we use 3 letters. ADB is congruent to CBD because they're alternate interior angles. And then again we look and we have a shared side. Anytime we have a shared side or a shared angle, it's congruent to itself by reflexive property. So notice now what I have marked: angle, angle, side, angle, angle, side. So the triangles are congruent by angle, angle, side. Moving to example 1, our given angle S is congruent to angle U. And we're told that segment TR bisects angle SRU. And the bisector splits, in this case, an angle into two congruent angles. So somewhere in our proof we can introduce that, and then notice again we have a shared side. So as I look at my diagram, I have angle, angle, side, angle, angle, side. So now we can fill in the proof. Angle S is congruent to angle U, TR bisects angle SRU. This is given. Okay. Angle SRT and angle URT are congruent, and that is by definition of angle bisector. Segment TR is congruent to segment TR. That is our friend, the reflexive property. So now we know our two triangles are congruent by angle, angle, side. Moving on to example 3, the diagram looks the same, but they're giving us a little bit different information. Okay, we're given that S is congruent to U, but we're told that these two line segments are perpendicular. So this is going to give us right angles. Now, you may want to jump to conclusions that this is going to be hypotenuse leg, but we need to walk through everything else before we can decide that. If I look here, I want to prove that RS is congruent to RU. Well, notice RS and RU are the hypotenuse of each triangle, so we're not going to be able to use hypotenuse leg. Here we need to find it and then use CPCTC, which means the triangles need to be congruent. So we're going to have to take a different direction on this. So first we do our given. Angle S is congruent to angle U, and segment TR is perpendicular to segment SU. That's given. Now, we can still take advantage that we have right angles because we also know that all right angles are congruent. So I can go ahead and state that angle STR and angle UTR are right angles. And this is based off of definition of perpendicular. Now I can say that angle STR is congruent to angle UTR because all right angles are congruent. Okay. Looking back at my diagram, I have a shared side which will be congruent under itself. So TR is congruent to TR by reflexive property. So that means our triangles, triangle STR is congruent to triangle UTR by angle, angle, side. So we've proven our triangles are congruent. We can now make our final statement. Segment RS is congruent to segment RU by corresponding parts of congruent triangles are congruent.